All right, number 17. Given the graph of the derivative, f prime, on -4 to 4, find the following. And first of all, if you notice really quickly, this is inclusive. So that means that if we are looking for maxes or mins or points of inflection, etc., we can include the endpoints. So this is the derivative. So this is a graph of slopes. Okay, keep that in mind. Okay, so in what intervals is f increasing? Is the function increasing? Well, the function is increasing when f prime of x is positive. And this is f prime of x. So where is it positive? It's positive above the x-axis. And that will be, so let me just write it right here. F of x is increasing from, this is -3 to 1, and from 3 to 4. We also want to know when it's decreasing. It's decreasing from when f prime of x is negative. So this is my reason why, by the way. I'm just writing my reason why here. So f of x is decreasing. It's negative below the x-axis. So that would be -4 to -3. And we can actually include that endpoint -4 because once again it's inclusive right up here. And it's also happening from 3 to 4. Including 4, not 3. All right, where does f have critical points? Well, we have critical points everywhere the derivative f prime of x equals 0 or does not exist. So let's look in here. There's no places where it doesn't exist because I don't see any holes and I don't see any asymptotes, but I do see 3 locations where it equals 0, which would be -3, 1, and 3. So that would be -3, 1, and 3. Where does it have a relative max? Okay, so it could have relative maxes for 2 reasons. It could have a relative max because f prime of x goes from positive, which means increasing, to negative, which means decreasing, and that would leave us with a max. So let's look up at our graph. We have right here f prime of x is positive, down here it's negative, which makes this a local max. Nowhere else does it go from above to below. However, once again, we have to include our endpoints. So if I have a point on my graph and I have a left endpoint on my graph, so I draw a point and I have a negative derivative directly to the right of it, this means that the graph is decreasing. So I draw a point, I have a negative derivative, which means I'm decreasing. So therefore that makes this point a maximum as well. How about the other endpoint? We have positive first derivative, which means the function is increasing. And we're increasing, and then end. Which if we were drawing the function, that means I would be going up, 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 and I would end. So that would make this a maximum as well. So where do we have relative maxima? Well, that would be at x equals -4, +1, and +4. All right, how about minimum? So let me do this in a different color. Right here. So relative minima occur when f prime of x changes, or change, from negative to positive, meaning going down to going up, right? And it would have a point in the middle. So we've already knocked out both the endpoints of the maxes, so really we only have to worry about now places where it goes from negative to positive, which would be right here. This would be a min from negative to positive, and right here, this would be a min too. So this occurs when x equals -3 and +3. All right, next one. What does f have inflection? Sorry, where does f have inflection points? Okay, so inflection points have to do with the second derivative, and that's when the second derivative changes sign. It can be going from positive to negative or negative to positive. Okay, but we're looking at the first derivative. So let's look at D right down here. F double prime of x is the derivative, which basically means the slope, of f prime of x. So f double prime is the derivative or the slope of f prime of x. So let's look here. Here we have a positive slope, right? So here, f double prime of x is positive. It's going to change. And from here to here, we have a negative slope of our graph. So f double prime of x is negative. Finally, from here to here, we go back to having a positive slope, so f double prime of x is positive again. So inflection points occur when we change sign, and that's going to occur right here at about -1 and right here at about 2. What intervals is the function concave up, concave down? Well, we've already kind of answered that question. Concave up means f double prime is positive. Concave down, f double prime is negative. I keep doing that. Is negative. So let's look here at E. F double prime of x is positive from -4 up until -1. And 2 to 4. F double prime of x is negative in between those two. So from -1 to 2. Okay, moving on. Similar type of question, except now we're specifically talking about a velocity graph. But velocity is, once again, it's the derivative. This is f prime of x. So what you're looking at here are a bunch of slopes, okay? And slopes of the position graph. Okay, so the amazing Fortini is walking along a tightrope 70 feet in the air. His velocity at time t is given on this graph below. So this is the velocity that he's walking along this tightrope. We want to know, when does he change direction? Well, changing direction is like a critical point on a f of x, right? Basically, it's where he's going from moving forward to moving backwards, which is where his velocity changes sign. This is going to occur when velocity changes sign. Okay, so velocity is positive above the x-axis, negative below the x-axis. So we can say that he changes direction when x equals, or I'm sorry, in this case, it's time. So when t is equal to 7. When is his speed the greatest? Well, speed is actually the absolute value of velocity. So it's everything about velocity except the sign. We don't really care about the sign of it. We really just care about the number part. So I see up here we have the biggest velocity has a value of 3, and down here the biggest velocity has a value of -4. So if I took the absolute value of -4, that would be bigger. And so that's going to occur when t equals, I'm going to say about 10. All right, finally, what is his acceleration at 6 seconds? Well, the derivative d dt of velocity is equal to acceleration. What this means is the slope of velocity is equal to acceleration. You can think of it like we're really talking about the second derivative here. So what's his acceleration at 6 seconds? 6 seconds is right about here. Ooh, right about here. 6 seconds. So what's the slope of this line? I'm going to take these 2 points. It looks like at right to get from here to here, we're going to go down 3 and over 2. So acceleration is equal to, okay, 3 divided by 2. There you go. 3 divided by 2.